Assalamualaikum. Today we are presenting our project titled Banking Transaction Manager with Fraud Detection. Our team members are myself, Mohammad Rakib Hasan, MD Shariar Tamim, and Abdul Qayyum. This system manages bank accounts and transactions using data structure and binary search trees, stores account and stack, tracks the transaction history, and queue handles suspicious transactions. I'll explain the binary search tree, which stores all bank accounts. We use binary search tree because it allows fast search and sorted data access using account numbers. In this BST structure, each node stores account details. Left child has a smaller account number and the right child has larger ones. In this BST class, the BST has a root node which stores as null and when no account exists. In this insert helper, this keeps the tree sorted and efficient. And to search an account, this function searches an account by account number and it is used in deposit, withdraw, and check balance, and fraud review. The time complexity for this is log O log n and space complexity is ON. Let's move on to the live demonstration. By pressing the number 1 option, let's add an account. The account number is 100102. Name is Hasib. Initial balance is 20k. Account successfully created. By using the number 1 option, we add an account by using BST search. And now let's check number 4. Check balance. The account number is 102. And as we can see, this option uses the BST search to quickly find the account and display balance. Let's move on to the number 6 option. Let's press. As it requires an admin access, we use the default pass, which is admin 123. As we can see that this displays all account using in-order traversal, and no account appears in so the accounts appears in a sorted order. So BST handles insert, search, and sorted display efficiently in our system. In conclusion, BST efficiently manages bank accounts with fast search and organized data. Now I would like to hand it over to MD Shariar Tamim, who will explain stack.
Hello, I am MD Shariar Tamim. I will explain how the undo transaction system works using a stack. So we use a stack because it follows the principle named last in first out. So let's go through the code. So here is that struct named transaction, which contains the user information like account number, type, amount. There's another struct called struct node. It has 2 pointers. One is data, which points the transaction, and another is next, which points the stack node itself. So the stack class, it has various functions like push when we add some information, then it will push or store it into the new node, and another is pop. It also has a pointer. It actually stores the most recent information as temp and then finally delete it. And here is boolean function is empty. When there is no transaction, then it will return null. There is something I need to add, that in the push and pop operation, our time complexity is actually order of 1, because there is no loop and we don't need to search something. We just randomly store or delete. Now let's run the code. So we will do deposit, withdraw, and undo last transaction. Let's start with undo last transaction. it sent a message error, no transaction to undo, because there is no transaction in the transaction file. So it will return null into the isEmpty function, and generally shows this message. Now we will deposit and withdraw money. So when we deposit or withdraw money, it pushes the information or history into the text file one by one. So now we can run the last transaction, undo the last transaction, sorry. So here it pop or removes the most recent history from the file. So that's how the stack actually works. Now I will hand over our next part to Mr. Abdul Qayyum.
Assalamu alaikum everyone. I am Abdul Qayyum. In this part of the presentation, I will be explaining the queue data structure implementation for fraud detection in our banking transaction manager. In our banking system, we used queue data structure to store suspicious transactions that require admin approval. The queue follows the FIFO principle, so transactions are reviewed in the exact order they are detected. The queue is implemented using a linked list with font and rear pointers. This allows both NQ and DQ operations to work in off on time. Each transaction in the queue stores the account number, customer name, transaction amount, and also the transaction type. Now let's see our fraud detection logic. A deposit transaction is flagged as suspicious if the amount is more than the threshold, and also same for the withdraw. Withdraw transaction is flagged if the amount is more than the threshold or more than the 80% of the current account balance. When a transaction meets these conditions, it is not processed immediately. It is added to the fraud queue and marked as pending until admin approval. Now let me demonstrate how this works in practice. So first we need to compile our system. The compilation done successfully. Let's run it. We have a option 9 set for detection threshold. By default it is set at 50,000. So first I will attempt to make a large withdrawal. Let me select option 3 for withdraw money. Now I will enter account number 1003, which belongs to Rakib. So we will go with amount 60,000, which is above our 50,000 threshold amount. Notice the system response. It displays warning message: suspicious withdrawal requires admin approval. And the transaction status shows as pending. The money has not been deducted from the account yet. This is our fraud detection system working as intended. Now let's view the suspicious transactions queue. I will select option 7 for that. Here we can see our queue displaying all pending transactions. The transaction is currently waiting in the queue for admin review. Now comes to the crucial part, the admin review process. Let me select option 8 for that. We need to put admin password. So access granted. Now the system presents the first transactions from the front of the queue, demonstrating our FIFO principle in action. It displays transaction details The admin is given two options, A for approve and R for reject. I will approve this transaction using A. Perfect. The transaction has been approved. Notice the balance successfully updated. Previously it was 1 lakh. After withdraw complete, now it is 40,000 taka. Let me verify the queue has been cleared by checking option 7 again. So here we can see no suspicious transaction, mean now our queue is empty. The three main operations are NQ, adds transaction to the rear in off on time. DQ removes from the front during review, it is also off on time. And the display shows all the transactions, pending transactions by traversing the queue. To conclude, our banking transaction manager uses three main data structures: a binary search tree for managing accounts in a sorted order, a stack for transaction history and undo operations, and a queue for fraud detection. This project shows how basic data structure can be used together to solve real-world problems effectively. Thank you very much for watching our presentation.